Good morning. This is going to be Unit 1, Day 1, Functions and Graphs of Pre-Calc. First, we're going to talk about functions and a relation. A relation is a correspondence between two sets, a set of ordered pairs. The domain is going to be the set of all input values. Remember, this is our independent variable. Usually we use x. The range is a set of all output values or our dependent variable, and we usually use y. Go ahead and pause it if you guys need extra time to write this. F of x is function notation. F is the name of the function. A function is a special relation between two variables such that to each value of the independent variable, or x, called the domain, there corresponds exactly one of the dependent variable or range. And I'm going to explain to you what that means. First, there are different ways to represent a function. We do it graphically, or points on a coordinate plane, and the input is going to be the horizontal axis. This is x, and the output is the vertical axis, or y. Numerically, we can represent this by a table or a set of ordered pairs that match. Usually it's going to be, or it's always going to be input and then output, or x, comma, y. Algebraically, we can represent it as an equation in two variables, and as words, describe how an input variable relates to an output variable. We're going to see some examples of that. We see this as an ordered pair. These are examples of a relation. This one is not a function. We have the same x value with different y values, so this is a relation only. Since x equals 2, maps, we say it maps to two different y values. B, the area of a circle is a function of the radius. So what this means is the area of a circle is equal to pi r squared. So this is a function in terms of the radius. And this is a function. It's a type of relation. This is a function. The area depends on this radius. See, it says we have a friend. These are our friends, and this is the birthday. Since every friend is distinct, this is also a function. And you guys can write every input is unique. These are each unique people. Alrighty, do you see that this one right here, example 2, we have the same x value. These are not distinct. So this is just a relation, not a function. It looks like this, each x value goes to its own y value. This is a function. We have distinct x values. When we have something graphed, we can check to see if it's a function by the vertical line test. If we draw a line everywhere through this graph, and it only touches these vertical lines once, then this is a function. For function notation, we say f of x. We write that, or we say that as f of x. G, or f, g, and h are used to name functions. F of x equals y, or the value of f at number y, or at number x equals y. F at 2 equals 9 means that we can write this as an ordered pair. The input is 2 and the output is 9. And that means that this is on the graph. To evaluate a function, I'm going to remind you how to do this. Our function, they say f of x, f at x equals 2x squared minus 3x. Now what we're going to do is substitute 2. F at 2 equals 2, parentheses 2 squared, minus 3 times 2. Just make sure you use your order of operations. 2 squared is 4, so 2 times 4 minus 3 times 2 is 6. And this is 8 minus 6, so f at 2 is 2. I did that pretty quickly. Let's try this one. So we know f at 2. We know f at 2 is 2. Plus f of x, which is this. So this is 2x squared minus 3x. And I mean, I would just rewrite it to make it nicer. So f of x plus f of 2 equals 2x squared minus 3x plus 2. And there's really nothing else we can do to this. I want you guys to try this one. And try this one. What I'm going to do is I'm going to show you how to do G. So if you guys needed help on those, G will definitely help you. I'm going to help you with this. So the x plus 2 is very similar to this. This one is x plus h. So just to remind you, our formula is, I'm just going to write it down, f of x was 2x squared minus 3x. And what we're going to do, instead of substituting in a number, we're going to substitute in x plus h. So f of x plus h, wherever I see an x, I'm just going to substitute in x plus h. 2 parentheses x plus h squared minus 3, and then I see an x, so this is also x plus h. And remember your order of operations, we squared this first. So 2 parentheses, when you're squaring a binomial, something with 2 terms, we have to FOIL it. So this is actually x plus h times x plus h. And then I can distribute this. Negative 3 times x is negative 3x. And negative 3 times h is negative 3h. So when I FOIL this, remember I do the first term, which is x times x, which is x squared. My outer 2 terms, which is xh. My inner 2 terms, which is also xh. And then my last 2 terms, which is h squared. Then I need to distribute the 2. I'm just going to rewrite the rest of it. Minus 3x minus 3h. And then I'm going to distribute that 2. So I'm going to bring it up here. So I have 2 times the x squared is 2x squared. This is xh plus xh, that's already 2 xh's, and then I'm multiplying it by this 2 out here. So this is going to be 4xh plus, so I did this one, 2 times h squared is going to be 2h squared. And then these are actually minus 3x minus 3h. And I do not believe we can actually simplify this at all or combine any like terms. So this is our answer. This is it. We're going to use this a lot, so don't forget it. So we have characteristics of a function. Each element in A must be matched with an element in B. Some elements in B may not be matched with an element in A. This one is very important. Two or more elements in A may be matched with the same element in B. So what this means is 7 can go to 52 and to 56. That's okay. We can have the same element in B. However, the reverse is not okay. An element in A cannot be matched with two different elements in B. Okay, so actually this 7 cannot be matched with 52 and 56, but two or more elements in A may be matched with the same element in B. So 7 can be matched with 52 and 6 can be matched with 52. That's okay. All right. So the domain in this one would be, we can write this like this. 6, 7, 8, 9, and 10 are going to be my domain. My range are going to be the numbers that it's mapped to. So my range is going to look like this. 52. 7 goes to 55. 8 goes to 59. 62 and 66. And if we want to write them as a set, we'll write them as an ordered pair, which would be something like this: 6, 52, 7, 55, and 8, 59, 9, 62. It's pretty straightforward. 10, 66. Oops, 10, 66. Sorry. Alrighty. Finding a specified domain, I just want to go over how to graph this. They're saying that this is what the graph looks like. Y equals 2x minus 3, which is a straight line. But it only works between when x is -2 and when x is 3. We can actually include -2 and include 3, so you can actually use those numbers to plug it in. You can make a chart, or this is just a straight line, so we know how to graph these. We start at the y-intercept, which is down here at -3. That's a point. And then we use a slope. Our slope is 2, or 2 over 1. So we're going to go up 2 and then over 1. Do it again. We really only need 2 dots to form a straight line. And this is going to be our line. And it only goes from -2 to 3. We cannot go past these. You can go ahead and complete the table for this. We're just going to substitute in these numbers. -2, we plug that into, or substitute that into x squared. This is going to be 4. -1 into this x squared gives us 1. 0 squared, 0. What happens when we substitute in the square root of 3 into the x squared? Well, we get the square root of 3 and then square it. And the square root and the squares, they cancel each other out. And that's just going to be 3. You can finish this. And this one, they just show it in a different way. This is showing it as a mapping. So if our x are these numbers, and our g of x is equal to the square root of x, then we're going to substitute in the 0 into this, and we're going to get the square root of 0, which is 0. 0 maps to 0 in this function. 1 maps to 1. The square root of 1 is 1. 2 maps to the square root of 2. I don't know. And you guys can do 3. 4 maps to the square root of 4, which we can actually figure that out. That is 2. Implicit versus explicit. If you can solve the equation in terms of y, or for y in terms of x, then it is explicit. So if we have something like 5x squared minus 2y cubed equals 4, this is implicit. And if we have something we can solve in terms of x, so we're going to get y equals something, then this is going to be explicit, like y equals maybe 3x squared minus 2x plus 7, right? Y equals something, that's this one, explicit. So it says, given implicitly defined functions, solve each for y in terms of x. We want y equals something. Then state whether the equation represents y as a function of x. So let's try this one. We have 2x plus 3y equals 5. I'm trying to solve this in terms of y. So I'm going to subtract 2x minus 2x on both sides. And I have 3y equals, I still have the 5, minus 2x. And then my last step is going to be to divide by 3. And we can solve this for y in terms of x. Our answer is going to be y equals, I'm just going to bring this up in front, negative 2x over 3 plus 5 over 3. So we're going to say yes. And this is linear. Now this one I kind of wanted to show you, see, this one was a little difficult, or it looks a little complicated. We're trying to solve this for y in terms of x. So what we're going to do is isolate y. And in order to do that, we have to divide by x. So we're going to get y equals 1 over x. So we can also do this one. You can say yes. And it is rational. You guys can try the other two. This one, I want you to use your graphing calculator to graph these. And then we can find the domain. Remember, the domain are your x values. And we're going to write it in interval notation. So this is a hyperbola. And it looks like something like this. I know it goes through negative 3 and 3 and looks something like this. You guys can graph it to check it out. So what a hyperbola looks like. So my set of x values, or my domain, is going to be negative infinity all the way up to negative 3. And it includes negative 3. It goes through that point, negative 3, 0. And then union, and it does include 3. So I'm actually going to use the bracket, not parentheses. Union, and this one starts at 3. There's no x values in between here. So this one starts at 3. It includes 3 all the way to infinity. We never include infinity. It's not a number, it's a concept. So we have parentheses. Alright guys, this is the last one I'm going to try today. I want you to try the rest and let me know if you have any questions. Have a wonderful day.